Hello, this is the Direct Instruction Guy, Mr. Stewart, and I'm coming to you from my trailer. Today we're going to talk about projectile motion, an application of quadratic equations. Projectile motion is when an object is thrown, tossed, served, launched, shot, but it cannot have its own propulsion or engine. We're going to focus only on things going straight up or straight down. Here's an example from the internet. And here's another example of something that is not projectile motion. What are the parameters? In other words, what numbers do we fill in the equation? There are three parameters to a quadratic equation: an a value, a b value, and a c value. The a value represents acceleration due to gravity. And here on Earth, near the ground, gravity accelerates objects at 32 feet per second every second. But for our equation, we have to use half of that. If you'd like a detailed reason why, you need to ask a physics teacher. And also, it's got to be negative 16 because gravity goes down and negative means downward. So therefore, every single one of these problems has an a value of negative 16. The b value is the initial or beginning velocity when it starts its motion. The moment you toss a ball and it leaves your hand, the speed or velocity it was going, that instant, that's the initial velocity. Now we call it velocity because it has a sign. It can be positive or negative. Positive means up and negative means down. If you drop an object, you just let it go, release it, its initial velocity is 0. The c value is the beginning or the initial height. Now sometimes you drop it from a height, like from a tower. Sometimes the object starts at the ground level. Remember, when the height is 0, that means an object is on the ground. H of t is the function of a height at a certain time. V with a subscript 0, or v sub 0, is the initial velocity, and h with a subscript of 0 is the initial height. Now we'll do some examples to see how to apply projectile motion. Question number 1. Tower, the one that leans in Pisa, Italy, is 186 feet tall. If you took a little marble and you dropped it from that height, how long would we expect for it to take to hit the ground? Well, let's identify a few things first of all. The problem gives us the initial height. H sub 0 is 186 feet. We want to know when the object hits the ground. That's the function value. That's our h of t. That would be 0. The marble's not thrown. It's not tossed up. It's not thrown down. It's simply released. So the initial velocity is 0. Substitute what we have into the quadratic equation. Here's gravity, negative 16. T's for time. There's no initial velocity. And we're starting from 186 feet. I'm going to use the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Identifying the parts or the parameters of the equation, the a value is negative 16, the b value is 0, and the c value is 186. Substitute into the quadratic formula now. First, we'll start with the discriminant. B squared minus 4ac. That would be nothing squared minus 4 times negative 16 times 186. 11,904. Now I'm going to substitute into the quadratic formula. Quadratic formula is usually stated with an x equals, but we're dealing with time, so I'll say t equals negative b plus or minus the square root of 11,904 divided by 2 times a, which is negative 16. We need to split the plus or minus into two separate problems, once with a plus, once with a minus. So we'll do that. It's going to be, now negative 0 is just 0, so we're going to ignore that part, over negative 32, and on a calculator that works out to be negative 3.4. Or, if we work with negative square root of 11,904 over negative 32, positive 3.4. Do we take both answers? No. The negative answer doesn't make sense here. That would mean going back in time from when you dropped the marble. So we're going to state that the answer is 3.4 seconds. It takes 3.4 seconds after the marble is released for it to hit the ground. A toy rocket is vertically shot upward with an initial velocity of 100 feet per second. It's shot from a height of 10 feet. You might be thinking, I thought in one of the videos you just showed that if the object has propulsion, then it's not projectile motion. Well, what we're going to assume here is that the rocket does a very quick explosion at its initial phase, and then after that, the rocket is flying without any propulsion. Let's identify the different parameters. We have an initial velocity given of 100 feet per second. So our v sub 0 is 100. The starting height is 10 feet. So h sub 0 is 10. The height as a function of time is negative 16t squared plus 100t plus 10. 3 questions here. When does it reach its highest point? Because it says when, that's a clue for us that we're solving for time. In an earlier lesson, we learned that to find the vertex of a parabola, we can use a formula called negative b over 2a. When it reaches its highest point, that will be a vertex. Negative b over 2a on this equation. The b value is 100. The a value is negative 16. It's 3.125 seconds. So that answers the first part. When does it reach its highest point? But the second question is, what is its highest point? To find the answer to that, we need to take 3.125 and substitute it into the original equation. H of 3.125, which is negative 16 times 3.125 squared, add 100 times 3.125, and add 10. 166.25 feet. That is how high the rocket goes. But another question is, when does it hit the ground? We're going to use the quadratic formula. So let's identify our 3 parameters. The a value is negative 16. The b value is 100. And the c value is 10. Substituting into the discriminant formula, b squared minus 4ac gives us 10,640. Now we're going to substitute into the quadratic equation. T equals negative b, or negative 100, plus or minus the square root of 10640 divided by 2 times negative 16. Now I made a special video off my iPhone to show you how to plug this into the calculator. Negative 0.1 and 6.3. Which one do you think is the answer? Yes, it has to be the positive one. It has to be 6.3 seconds. Now let's look at the graph on Desmos. And you can see that the highest point is 166.25 feet. You can see the x value is when it reaches that height at 3.125 seconds. And you can also see the x-intercept of approximately 6.3, 0. That is when it will hit the ground again. It's been a real pleasure. Let's do this again sometime.